Hello everybody, today we're going to be going over the quadratic function and example for the IB Math Studies level. So, the problem tells us that we have this graph right here with this form. The point A, 0.5 intersects the y-axis, and we have the vertex at the point B, 2, 9. So, part A asks us to find the value of C. Now, C is always going to be y-intercept. Okay? When we're looking at the form of ax squared plus bx plus c, c is always going to be the y-intercept. Why is this the case? Because of all the values in this formula, it's the only one without an x. So if we say that x is 0, this goes away because it's going to be multiplied by something. It's going to be a times 0, it's going to be b times 0, and c is the only one that is unaffected. So we will be asking the graph at the point 0 for x, which value of y do I get? That is why C is always going to be the y-intercept. Okay? So when they're asking for C, they're really asking for the y-intercept. And thankfully, as the problem gives us, the point A at 0, 5, here x equals 0, so 5 has to be the y-intercept. C is equal to 5. For part B, it asks us to find the value of B. Now, they give us the vertex at the point 2, 9, right? And the thing of the vertex is that it could be a maximum or a minimum, but it is always the point in the middle. This is because quadratic functions are perfectly symmetrical. Therefore, going for the formula sheet, we have this right here. X equals negative b over 2a, which is the equation of the axis of symmetry for the graph, for the quadratic function. So, if you plug in 2 for x, you will leave b as a variable. And then we have 2a, and we know that a is equal to negative 1. I pass the negative 2 over to the other side by multiplying, so 2 times negative 2 equals negative b, negative 4 equals negative b, b equals 4. Now, how did I know that a was equal to negative 1? Well, because looking at the formula, this guy right here, its generic form is like this. It's ax squared plus bx plus c. And so these a's, b's, and c's are like the constants that either accompany the x or are alone like this one. So that is why I say that a is negative 1, because it's the one next to x squared. We know that given what the problem told us, a is going to be negative 1 because it's what's accompanying x squared right there. So that would be part B. Okay, and for part C, it tells us to find the x-intercepts of the graph of f. Now, there's two ways to do this. You can either factor or use the quadratic formula. I prefer using the quadratic formula because it never fails. It can be more tedious, but as I said before, it never fails and there's no way you can mess it up. So, the quadratic formula is negative b plus minus square root of b squared minus 4ac divided by 2a. Okay, and as I mentioned before, this is the generic form. So we organized our values in order to have it in this form, right? Using the values we obtained in a and b, we would end up with negative x squared plus 4x plus 5. And from here, we can say that a is negative 1, b is 4, and c is 5. So plugging these values into the quadratic formula, we end up with negative 4 plus or minus square root of 16, 4 times 4, minus 4 times a times c divided by negative 2. We end up with 16 plus 20 divided by negative 2. negative 4 plus or minus square root of 36 divided by negative 2. Square root of 36 is 6 because 6 times 6 gives us 36. So negative 4 plus or minus 6 divided by negative 2. Now, because there's a plus or minus, we're going to go two directions. We're going to go the direction where we end up with plus 6 and the direction where we end up with negative 6. And so in this scenario, we end up with 2 over negative 2, so negative 1. And in the other scenario, we end up with negative 10 divided by negative 2, which gives us positive 5. Now, the reason it's plus or minus is because we have two zeros. And since it's symmetrical, that's why it's positive or negative. So our zeros would effectively be negative 1 and 5. So that is part C. Finally, part D says to write down f of x in the form negative x minus p, x plus q. And so what it's telling us is that this p and this q are the zeros, because that is the generic form for when you factor something, right? Since there's a negative outside of these two, I'm going to factor out a negative right away. We end up with this, x squared minus 4x minus 5. And since we know that the zeros are negative 1 and 5, we can leave it like this. X minus 5 and x plus 1. Okay, the reason like the symbol is like turned around, or so to say, because here it's positive 5 and here's going to be negative 5, it's because once we equal this to 0, in order to find the zeros, of course, one of the two has to be 0 in order to make this statement true. So this is what we would state. And from both of these, we end up with x equals 5 and x equals negative 1. Okay, that's just explaining why it's done this way. But this right here is enough for part D. Okay, I hope it helped out. And I insist that the quadratic formula is always going to work. Factoring can get kind of tricky sometimes. So for me, I prefer to do the quadratic formula always. But you do you, and I hope it helped.